Alright, so I'm here at the Raylib website, and I assume you probably know what Raylib is. If you don't, it's basically a library that has audio, visual, and text, and a lot of other things. If we go to his example here, you can see it's got all of these things here, and we can also go to the cheat sheet, and here is all of these commands. And if you're going to learn it, you want to keep this page up. You also want to keep this one, the examples, to just say if you want to look at like, how do I display text? You find one of these examples here, and for example, you go into the code and you can see how it's all done, for example. But the first thing is, how do we even use it? How do we even like install it, use it, etc., etc.? If you're on Windows, this video is more for Linux, but if you're on Windows, you basically just go to the itch.io and you can download it here, and you get the min.g compiler version. You're going to have to combine that with your IDE, or if you're compiling it. I'm actually not sure how you compile via terminal on Windows, but you'll probably do something like that. Anyway, for Linux, if we go to the wiki and then we go down, you'll get working on GNU Linux. Alright, so here we need the required tools. So you're going to have to open your terminal. Okay, hopefully you can see everything here. So we have the required tools, which is sudo apt install build essential git. And here we just paste that in, type the password. And I've already got it installed, but it'll install all of these things. Optionally, you can use CMake. So I believe this one's more make, and this one's CMake, which are... How do you explain those? You want to read more about make and CMake? Here we are. Automation tools used by software developers to automate the compilation and building of programs. Right. So basically to help you compile, by the looks of it. I'm on Mint, which is technically a Ubuntu system. So if you're on like a Debian or a Mint or Ubuntu or something, you'll do this. If you're on a Fedora or an Arch, don't know what you do if you're on like Void Linux or something else. Maybe if you look at these specific libraries, you might be able to get them on another distribution. So anyway, we'll just paste that. We've already got them, of course. Now we go down to build Raylib using make. So what we're doing is cd clone. We're doing this, and what it does is that it will download the Raylib files to your home directory, and I've already got them, so I'm just going to quickly delete them so I can show you this. Alright, so we can see here I've got my home directory and there is no Raylib file, so we're just going to copy this git clone thingamajig here. We're going to paste it in, and it's cloning Raylib, so it's basically just downloading the GitHub files. You can also do this manually through, going to Magic Code and downloading it. But anyway, it has successfully downloaded. Now what I'm going to do, this is an optional step. I'm going to go into my Raylib area, and I'm going to go into my src, and then I'm going to double click the config.h. And what the config.h opens up, alright, so here is the config.h opened up here, and you can see what we're going to go down to is here are textures configuration flags. Now the point of this is you can see that these ones define support format PNG1. It means that we can use PNGs, we can use GIFs, we can use QRIs, we can use DDSs and HDRs. But what if you want to use a bitmap file or a TGA or JPG or a JPEG, which is, this is the same. What we do, because I want JPEG support, I will delete this is a C comment. I'll delete the comment. You see, this is all commented in, all this stuff here, and this is all commented in. But this isn't commented in. Now it's changed its color, and then I'm going to go save, and then I'm going to just close this up now. So we're going to go like that. And now we go back to our page here, and we go copy CD Raylib source, paste it in here, and what does CD basically for the Linux terminal, it means that you're entering the directories. We can see we're in the Raylib source directory, or if I go into, for example, my folder, you can see on the folder here, I'm also in the Raylib source directory, which has all these files here. So we are cding the Raylib terminal. Hopefully that's a little easier to see. And now what we do is we have these three options of the web page. And the option that I want to select, because we got the first one, make platform equals platform underscore desktop to make the static version. Then we have the dynamic and shared version. And then we also have the web version. I personally want the static version. Now, to understand static, dynamic, all that kind of stuff, let me quickly take us to ChatGPT. Alright, here we can see in the ChatGPT, what is the difference between a static and a dynamic C library? Static library, also an archive library, so it's like a .a I think, is a collection of object files, blah blah blah. When a program is compiled, the necessary portions of the static library are copied to the executable file. That's the main important things. Well, the dynamic linked library or shared library, when a program is compiled, it includes references to the functions and symbols provided by the dynamic library, but does not include the actual library code. So a static library, you're going to get a larger executable file, but you don't have to have the dynamic library with you. Well, I believe a dynamic library, is that like a DLL? Or a DLL file, I don't know, I think it might be, for Windows at least, is you're going to have it with you. So it's a .so, dynamic linked library. So it's DLL, basically. If you know what a DLL is, games come with DLLs. Otherwise, static is just, you're just compiling the whole thing, which I personally think is a lot easier. It's up to you though. Alright, so I'm going to select the static version here, so I'm going to copy the make, and specifically I'm using make. If you're using CMake, you follow these steps, but I'm using make. Go back to our terminal here, and I'm going to copy, paste, here we go. And you have to change that .h file if you want to change any of the specific things before you compile it, because what we're doing now is I believe we're compiling this. As you can see here, the terminal says Raylib static library generated raylib.a in source code, or src, and it's also got all of these core, lib, shapes, textures, text utils, etc. We also need to install it, I believe. So if you look it down here, it says install library to standard directories, user/local libs and user local includes, which I believe is it's installing the libraries to your computer, and you can use it from the computer for user local lib or user local include. Personally, I don't really understand how to do that, so I just copy it into my file, my folder, as we will see next. So here we go, sudo, I'm going to copy sudo make install. As you can see here, I've got it there, and I'm going to just go enter, and look at all this. There we go. It's been installed into these areas here, and we've got the latest version of it. Okay, now that's all done. As we can see, if I scroll down the page, there's nothing else really we need to do. This is all just examples. Install on GNU Linux, OpenSUSE. There's probably other ways. Anyway, this is C. Here I'm in my file directory, so I'm going to create a new folder, and this is going to be called video program 1. Okay, and we're going to go in here, and now what we're going to do is we're going to create, oops, excuse me, oh, that's fine, actually. Create a folder and call it lib. So we make a folder called lib, and we also make a file which is called main.c, and this is your main.c file. Now we also create another text document which we'll call compile, and what we're going to do is we're going to go to our Raylib src, which we've got right here. You see our Raylib src, and we're going to copy the files raylib.h, raymath, and rlgl. We'll copy those and we'll paste them into our main folder here. Now you can probably copy them into like a header folder or something like that and reference them, but I think it's just easy to do it this way. Now we'll go back to our Raylib source files. What I'm looking for here is a here we go, raylib.a. So we copy the raylib.a, we go into our lib and we paste it in lib. So hopefully you've got this right now. You've got a main.c, you've got a compile, these are both text files, and you've got the raylib.h, raymath, and rlgl.h, and then in the lib you've got the raylib.a. Now what we're going to do for double click the compile. Alright, so we're in the compile. Now what we want to do, because we're using the GCC compiler, I imagine you've already got it installed. Should come by default with pretty much every version of Linux. Here I have a pre-prepared version of it. As we could see, it is GCC, which invokes the GCC compiler. Then it is main.c, meaning our main.c file, and then /o. This one you invokes basically the ability to name the executable. Then we have program.exe. You can name it like program.o. You do program.moe. You do whatever you want. And then -L -L./lib essentially says your lib files, your .a files are in here /lib, which if you remember, you can see here is our /lib. Let's get that bigger. So they're in /lib. Then it's -lraylib and then another space and -lm, which is math. That just seems to, for some reason you need the math one. I don't really know why, but you know, that's what we do. So I'll put that in the description if you need to copy paste it, and we just save it and we can exit out of that, and then we get back to the compile and you right click compile. So you right click and click properties, as we can see, and then we go to permissions and we go on execute, allow executing file as program. And then we close it, and what happens now, if we double click compile, it'll come up with a window that looks like this, and we can click run. So here I've got open the main.c. Now we're going to, and you can do this in a text editor, like a a code IDE or whatever. And what we're going to do is we're going to go back to the example page of Raylib. So here we are in examples, and we'll just do a basic window. So we scroll down to the text, and we can see the text is all here, and we just copy the text, and you can see it's got include raylib.h, that's including our .h, and we'll go back to our main.c like so, and we'll paste it in. As we can see, look at that, isn't that nice? What we're going to do, double click our compile, and then we go run. And look at that, we have a program.exe, and I'm going to double click that. Here we go. We got our basic window, and of course on my screen it looks a little different because I'm just using like video magic, but it actually looks like a window. For example, I'll quickly give you a look at what my screen looks like. Alright, here's a quick screen capture. For example, as we can see here, this is what it will look like, and we can just rerun it. Example, we can go back to compile, run. There we go, window. So hopefully you have a window that functions, and now you can pretty much just program in Raylib and have a good time. Alright, so here we have Genie opened, and you can also use a text file if you want to use that, though it's a little bit more difficult. I like this because it tells you, just say you do that, you try to compile, oh, we got an error, okay, we need to do that. And for example, if we go to build and set build command, that same thing we wrote up is right in the #1 compile. So all you have to do is copy that to the compile error, you go okay, and then you click this button with the arrows, compile the current build, and you'll compile it, that exe file, if it is compilable, if it actually works. Now for our code here, I'll just enlarge. For our code here, we also have the raylib.h opened. This will give you all of your commands as well. Just, it's good to have this opened. Here we go. See, for example, you want to type text. Well, actually, it's probably not the best thing to type because there's a lot of things. You can, you'll figure it out. Going back to our code, here I've copied the basic window application, and if I run it, window, and it looks like this. So what we're doing, I recommend you start off with the basic window as a thingo, and I'll explain the things. Firstly, we have our headers here. I believe they're called headers, .h files. So usually it's like, usually you will include things, studio.h, stdlib, string, etc. That's for another project that I'm working on. I've got all those things there, but we'll add them as we need them. And of course, firstly, as you probably understand already, if you know about C, this is our int main void. It's our entry function, and it returns a 0. Basically, that means it's all good. So we can see here, we just have our entry function. It's got a little thing to tell you that. This is to initialize the window. So here is our initialization in the main function area. So personally, I'm going to have for example, my variables here. If I need anything, and my functions, I like to have my functions up here. That's just how I like to do things. That's how I'm going to do it. But for Raylib, first we have this const int screen width equals 800, const int screen height equals 450. And then we have init window screen width screen height. So if we go back to our Raylib init window, this is the window related functions. So all of these functions are related to modifying and doing stuff with the windows, and they explain all what they do. And you can go on ChatGPT if you need to. ChatGPT will explain all of these things. You can just say, what does init window mean? And I imagine you already understand a bit of C, but otherwise we have void, meaning this does not return anything. Like for example, this is a boolean, which is a yes or no. Window should close. It's either going to be a yes or a no. So it's a bool. A void, it doesn't return like a value or anything. Instead, it does stuff. It modifies stuff, I guess you'd say. So init window, and then we have int width. So it takes an integer, and then it takes another integer for its height and width. Width, of course, you're going to need to understand what width and height is. So instead here, we could do the same thing, would be 800 for width and 450. Now, and then we need a const char for the title, meaning Raylib core example basic window. So I'm just going to call it window. And of course, it's a char or character, so it needs to have these quotation marks. So now we've modified that, and I'm going to recompile, and then I'm going to open the window, and you're going to see the window here. Okay, that's nice. And now what we're going to do is we're going to close it, and we're going to modify this to say 1200 and maybe 800, and I'm going to recompile, and then we're going to open it again. Just FYI, I actually forgot to close the first window. So what you're seeing is the first window. You're not seeing the second window that I programmed later on. All right, so I've got a nice window set up. Now, It says set target FPS 60. This is how you set your FPS. I find if you don't do this, you have, for some reason, I have like serious issues, serious like memory and RAM, RAM and CPU errors. I don't know why. Probably because it's rendering at like stupidly high FPS or something. So we want to limit the FPS. So you can put it on about 60 or 30. And here is the main game loop, which is the while loop here that we see here, and it ends here. It says while not window should close. Detects if you close it or use the escape button. It's automatically set to escape. You can change the escape or the exit button later on. And then we also have begin drawing, and also window close is after here to close the window and close the OpenGL. I think it normally should if you just exit out of the application, but this is kind of like a helping thing. So anyway, as I said, you got your headers, you got your variables, you got your functions, and you got your main function. And maybe if you want to put structs or something, I just put structs and variables. In your main, inside of the main, we have your initialization, which is where you initialize certain variables, textures, fonts, I forget. You basically, music, you're initializing music, so you initialize things here. And this is your main while loop. This is, where the action happens. A while loop, of course, it's basically your, I don't know how delta time works with Raylib, or if you use, I think you use FPS. In games, in creating games, you have to have a time. Usually it's based on delta time, which I think is like the clock time or something like that. Otherwise, you can have it in FPS. So you could say every 60 frames, I want something to happen, which means every second, or you can do every 160 frames. So you need some kind of measurement of time, I think Raylib uses. And then we have begin drawing. Begin drawing is basically how you draw your text and visuals. Okay, so here's our root folder, and I've made an art folder, and I've got purple back and square, which is background and just a basic square. So here we're going to go to our program, and for example, if I want to initialize the textures, we go texture or texture 2D, and then we name the texture. So this is initializing the variable or the data type, I guess. And then we do background equals, here we go, texture 2D load texture. Okay, and it is, you can see here it's a const char and a pointer file type. Okay, so we have to, I think it's load texture, and you can see here it comes up, which is nice. You can also do this image manipulation. I'm not sure about this one. Supposedly loads it into GRAM or video VRAM, graphics RAM, while load to image, the image one loads into CPU or regular RAM. If anyone knows how to only load textures at a certain point, do tell me, because I'm having memory issues by loading too many of them. Going on. So here we need to have where our file is, which is art, because we go from the root directory. So here we can see our root directory, and then we can see art, and then we see purple back.png. So what we want to do is type art/purpleback.png, and then that, end it, compile. Okay, and then we want another texture 2D. So this is essentially you're preloading in the textures into your hardware. And then we do square equals load texture art square.png. There we go. And now if we want to display these, for example, we do draw texture. Here we go. This is to draw your textures, and you can see it takes a texture or a texture 2D right here. I'll get rid of this for you. It takes a texture 2D, and this one is the most basic. You'll notice in Raylib there is a very basic function Then there is a more advanced one. See, this one takes a vector 2, and a vector 2 is essentially just an XY position. So these are the same, except this one takes a vector instead of 2 integers, depending on how you like to do things. Then we have the X, the rect, the pro, and the end patch. These are all for more advanced ones. You can read about them here. And just say if you want to do scaling, like you want to scale this with the window, you will change certain things. Now, what I want to do is firstly just show you X, Y positioning. So what we're going to do is, what's it called? Yeah, draw texture. Draw texture, and then it takes firstly we need to put our texture, which is background. Then we need to put an X and Y, which is 0, 0. And then we need to put a tint color, which we want to do just white in full in that. And then we should do compile, and I'll run it and I'll show you what it looks like. Here we can see our window. It's got a purple background. Very good. And 0, 0 is, you can see where my mouse is, not on the program, but at the edge here, kind of off to the edge. This is 0, 0. So then if I was to modify things again, it's X, Y, and X is the left and right, and Y is the up and down. So if I do 500 and we run our program, then look at that. This is 500 of a distance. And then, see, this is where things start to get more analog. We can do, because you're trying to nudge things. You're trying to nudge the X, Y values. You can see here. So I've worked out that about 700 is half my window, because if you divide, you can see here the init window. See that there? If you divide 1,400 in half, which is our width, it equals 700. Similarly, if you divide 800 in half, which is our height, which is related to the Y value, we'll do 400. It should be halfway down, and that is correct. So basically we've made a perfect quartering, though realistically the picture is way off to the side. We haven't shrunken the picture, we've just shrunken. You see where it renders from. This little edge is where the point in space where it renders from. Right, so this is our window. Now assuming this window like we had is 1,400, and usually it's going to be 1,000. It's usually going to be 1920 or 1280. I think, is that 720p? I forget. And it's by, so this is width, right, and height. I hope I've spelled that correctly. In our window that we've made, so it's from like here to there, is 800. Okay, so width by height. That means that if I have something at coordinate point 0, 0, so this is X, Y, this is width is, technically width is not X, but the plane of width to X plane is this. So it's this line. Y plane is up and down. So up / down. X is left / right. We'll get into modifying X and Y's later on, but we're taking an XY value for where do we want to render. 0, 0 is there. So that means if we split it in half, an X of 700 is going to be half the screen. So it's going to be, it's going to be 700. And then depending on our Y, again, if it's 400, it's in the middle. This is pretty much dead middle. Well, technically that's a dead middle, but whatever, you know, let's just pretend that was a dead middle, right? That's 700, 400. That's a point in space there. This is called a vector. Vector. Technically, it's a vector 2, and then it would be like, you know, x, y, right? That means if we then have 200, 700 instead, it's 700, 200, it would be here. If it was 600, it would be here, okay? Then if we change 7 to 9, maybe 9, it would be like here, so 900, 600 would be like here, technically more like here maybe, okay? Then, so basically we're going, it's like 1, 2, 3, 4, 5, 6, 100, 200, 300, 400, 500, blah, 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 to 900. And then if we went to, you know, 1,000 or 1,001, 1,000, 1.2, yeah, 1.4K is here, so in this end. So you can think here is 1.4K, which is, you know, the max width. Here is 0. Up here, that's for x. That's for the x value, and then half of this is 800. Okay, and then you half it again, 400, or here is, you know, 1,000. So that would mean that if we were working on the y, here is 0, here, and this is assuming that the height of the screen is 800, here is 400, here is 800, right? And then we halve these again, 200, this would be 100, this would be 300, and this would be, we do like this, 450. I hope you get the point of this, 450, then 500. See, I've split this into 2, like I could split this into 2, 250, and then 300 here, 300, and I could split that again into 275 and 300. So it's if you can think in this way, and of course, you know, 600, etc. If you can think in this way, where you're splitting things up, and you understand that the bottom of the screen traditionally is a larger value, and the the right side of the screen is a higher value for the x, and that the up and down is the y plane, the left and right is the x plane, you should be able to understand how to position things in a two-dimensional area essentially. And then 3D is exactly the same, except you are working with a x, y, and a z. The z is, you know, that's how you get 3 dimensions, and maybe we'll go over that in another video. Let's go back to the original stuff. Okay, so now we are back here. I've done my draw texture, and here is just my background. And here we're going to put our, maybe like a player or something, like a character, which is just going to be a draw texture background. And then we're going to put him in like around the halfway of the screen. So 700 by 400. And then a white. Oh, I've messed this up. I'll fix it in a minute. We're not doing backgrounds. We are doing square. And Raylib comes with a thing to draw rectangles. You don't need to, here, you got draw rectangle. Like what I'll do is I'll copy this, I'll put it here, right? And we'll do that, compile. First we'll just look at what this does. Look at that, there we go. So we got our rectangle, and you can see it's from this edge, it has rendered there. So if we want it in the center of the screen, I'm going to have to look with my eyes and think, okay, because this rectangle is 400 by 400 pixels. It's an important thing to realize. So what we're going to do is I'm going to exit this, and I'm just going to start slowly going backwards. And I'm like, all right, do that. And then we open the program again. And look at that, that's nearly there. So now I need to move him over on the Y plane is okay, so the up and down is okay, but the left and right, the X plane, I want to move them over a little more on the X plane, meaning that I need to make this about 500 and recompile. So that's like dead on center. Yeah, interesting. Okay, so there we go. That's how you position this. Now instead, let's say I don't want to do that. I want to use a draw rectangle V. Oh wait, no, I just want a regular. I just want a regular draw rectangle. Excuse that. We could do a vector, but another time. Here we go. So firstly, let's go from the back. So color tint, there are colors. Here we go. I found the colors. Okay. So let's make them gold. That's kind of cool. And you got to have it in capitals. There's also there's a way to, you can specify your own color, and you can specify a opacity, and you put that color in here, you put that variable that you made in here, by the way. So position X, we put them around 500, position Y, we put them around 200. I think that's what we had last time. And if we go width, so basically the side length and then height, 400, this should be the same. This should be the same as that picture. Instead of using a, yeah, look at that. Instead of using a, what do you call it, like a PNG, we've just made pretty much the same thing. And if I go, I think cyan is a sky blue. We go sky blue. So you don't, if you want to make like a super simple game, or maybe, I don't know, I figure like once I have kids, you know, they can just play around with making stuff with like rendering graphics without even needing to, you know, use stuff. Because this rectangle acts as your like entity, so to speak. Anyway, so that's basically the same as what we've done. We've just used the draw rectangle function. And let's go back to the Raylib cheat sheet. All right, so here we are at the Raylib cheat sheet. I can see here. And I want to tell you, so first, module core is stuff. Here we go, window related functions, cursor related functions, drawing related. Next is shaders. We don't need to worry about that too much. Time related, miscellaneous, file management, compression, input. So this is key down. And what I want to do is if bracket key pressed, and then we do bracket, and the key is key underscore, we'll do D. If the key is D, then what we want to do is we want to draw this rectangle. And we'll do compile, and then we'll run it. I wasn't able to get the footage of me pressing the key and the screen, but instead next we have the key down. Now one thing to keep in mind is that the next section there's a bit of an epilepsy warning because I flash lots of colors. So here we go. All right, look at this. So is key down, when I hold it down, we got that. Ooh, give you some epilepsy. Anyway, actually how you do that is you create a, I probably shouldn't be telling you this, but what we do, I just did a draw rectangle 0, 0, and we'll do it as big as the screen, so that, and then we want a red, is there? Yes, there's a red. Okay, and we want a red, and then we want a blue, and when you flash these, and anyway, whatever, I'm gonna make this 0, 0. There's got to be some way to, I'm sure I can do that. I don't know, I probably shouldn't be doing this, but I'll show you. I'll just, yeah, epilepsy warning, do not watch this look right into that. That's how you cause epilepsy, by the way. You just have to flash it like lots. There goes my future, what would you say, selling out. Anyway, they're not going to want me. Go back to the cheat sheet. Here we are. You can see, so alright, and then we go to shapes. The same way that we had that rectangle, that draw rectangle. Here we got the draw rectangle. You got the draw circle. You got the draw line. I don't know what the draw pixel does. Ellipse. You know, ellipse is like a moon. Triangle, poly, all these things. And there's a 3D draw shape in a minute. And draw texture is either texturing models and stuff, or it is, if we look down here, texture drawing function, which is drawing the pictures. Next is text. So you can modify the fonts, and then you're drawing text, and it's multiple different text functions. It can take a text. Here we see const char, which is your text that you add, and you can also have a font, which draw text ex takes a font. Here we go, models, which is the 3D models. I haven't really played with 3D yet. I've only really worked with the 2D, but one day I will. And then we have the audio. So you have to init the audio device first. It's pretty simple. And then we have structs here, and you're going to have to look at the raylib.h to see what the structs components are. As you can see, vector 2 obviously is XY, vector 2, 3 is XYZ. Image struct, texture, which we did texture 2D, etc. And we have the colors. So you look at the cheat sheet, and you've also got Ray Math. I haven't really looked at the Ray Math. Right. So I think this is, you can define, vector 2 in different ways. Interesting. If you want more vids on this, I can make them. Otherwise, I've probably taken like half an hour of your time. So I hope you enjoyed. Of course, feel free to check the links in the description or ask questions or whatever. And have a good day. Really, just as I said, look at the cheat sheets, look at the examples. Ask ChatGPT or some other chat algorithm language model for help, and look at the raylib.h, and really it's just your app applying your knowledge of C programming to the library, really.